students, good morning, good evening and good night, depending on which time you are going to observe this lecture. Welcome to the second lecture on aldehyde, ketone and carboxylic chapter. In this chapter, we will going to discuss the methods of preparation of the aldehyde and ketones. So in this lecture, we are going to discuss the method of preparation of aldehyde and ketones. This is K.K. Mukherjee in the Science with Mukherjee Sir YouTube channel. There are a lot of methods that we can see that are used to produce this aldehyde and ketones. The first one that we are going to discuss, that is the oxidation of alcohol. Oxidation of 1 degree alcohol and 2 degree alcohol. By using acidic K2Cr27 or alkaline KMnO4, you can able to oxidize these alcohols. 1 degree alcohol will produce the aldehyde, 2 degree alcohol will going to produce the ketones. But the reagents like a Collins reagent or the PCC, polydinium chlorochromate, and another, that is PDC, polydinium dichromate. All those reagents in presence of anhydrous CH2Cl2 is very much effective, because due to the absence of water, this reagent will oxidize this aldehyde alcohol up to the aldehyde itself. The further oxidation of the aldehyde to carboxylic acid is not possible. So these are the very desired reagent and which will help you the 100% aldehyde product. Otherwise, there is a possibility of the oxidizing the aldehyde to ketone carboxylic acid, because due to high oxidizing power of the acidic K2Cr27 or the alkali KMnO4. So reaction for this, and what is Collins reagent? Let us understand. The Collins reagent is it is basically, the formula is this is Collins reagents, and PCC is pyridinium chlorochromate. And its formula is C5H5 NH plus, here this no NH plus, and CrO3 minus. This is a complex compound, and this, if we use this reagent to oxidize the alcohol, it will going to produce the aldehyde only. Further oxidation will not be going to be there. So reaction of this equation PCC, it will produce RCHO and RCH2 R2. This is a secondary alcohol. PCC, it will going to produce the ketone. Okay. Second, that is a method that is used, that is the dehydrogenation. Dehydrogenation. In this dehydrogenation process, the alcohols, which are basically volatile in nature, has been used for this process. Dehydrogenation means you are removing one hydrogen molecule from the alcohol, and in this case the alcohol will be passed over a heated copper, and it will going to produce the, for primary alcohol it will going to produce when where passes is in the heated copper at the temperature 573 K, and it will going to produce the ACHO. You can see the one hydrogen molecule has been expelled out, so it will going to produce this. Another C2CHOH, this is the second degree alcohol, and we are using the same condition, so it will going to produce the ketone. Okay, now we are going to discuss the third one. Third one is the dry distillation. Dry distillation of calcium salt of fatty acid. In this process, suppose we are taking this salt, calcium formate, and when we dry distill it, it will going to produce the formaldehyde and CaCO3. Fourth method that is we are going to use, that is it is the Rosenmund reduction. The name of this reaction is Rosenmund reduction. This is the name reaction, Rosenmund reduction. In this case, acid chloride or this is air, means that we are using the aromatic ring. This chloride RCOCl, acid chloride with hydrogen, it will reduce in presence of PdBaSO4, barium sulfate, and it is partially poisoned in presence of sulfur or quinoline. So it will going to produce this aliphatic aldehyde, or it will produce the aromatic aldehyde, the benzaldehyde, and it will produce the HCl. Okay, this is Rosenmund reduction, very important reduction. Fifth way, that is the Stefan's reduction. Stefan reduction, it is also a name reaction, Stefan reduction. Here in this case, nitrile compound has been used to reduce it. Nitrile compound is this, that is, it is having cyanide group RCN, and this is in presence of the stannous chloride, SnCl2, plus HCl stannous chloride, it is going to produce this. This is called aldimine hydrochloride. Aldimine hydrochloride. And this is hydrolyzed in the warm water, H2O1. When it is in the warm water, it will going to produce the aldehyde and also it is going to produce the NH4Cl. This is the Stephan reduction. Okay. Now 6.6 reaction that is we are going to discuss. When this nitrile has been reduced in presence of diisobutyl aluminum hydride. Diisobutyl aluminum hydride, this is a good reducing agent, and it is also, it has a very important application that when there is a double bond presence in the alcohol, it will not going to break this, going to affect this double bond portion of this compound. So this has been used for this can be used in case of nitrile also. As for example, BS3 this is the name, IUPAC name of this compound will be hex 4-in 1 nitrile, because there is a 1 double bond present at the 4th position. And when this has been used by diisobutyl aluminum hydride, and it is correspondingly being hydrolyzed, it is going to produce this aldehyde where we can find the double bond is unaffected. Double bond is unaffected. This is the hex 4-in 1L. Okay, so this is diisobutyl aluminum hydride that can be used to reduce this nitrile. And another production reaction that is you can produce from the esters also. Ester that we are taking CH3, CH2 whole line, COO, This is undecanoate. This is a ester, and when this is being reduced with this diisobutyl aluminum hydride followed by the hydrolysis, it is going to produce the aldehyde. And this name of this aldehyde is undecanal. Okay, so we have discussed the 7 reactions by which we can able to produce the aldehyde. First the oxidation, then dehydrogenation, then we have dry distillation of calcium fatty acids, calcium salt of fatty acid, then Rosenman reduction, then Stephan reduction, and then we use the diisobutyl aluminum hydride, and then also again from the esters. 7 reactions we also discussed, and we will discuss another 3 reactions from which we can able to produce this aldehyde. And we have already discussed the 7 ways, 7 methods by which we can able to produce the aldehyde. Now we are going to discuss another, that is 8 number, that is the it will be the reaction with HCN, reaction with HCN, hydrogen cyanide, and Grignard reagent, and Grignard reagent, Grignard reagent. In this case, the reaction will be this H, and Grignard reagent we are using methyl bromide, magnesium bromide. This is the Grignard reagent. And now we know this Grignard reagent it is basically a minus charge and it is basically a plus charge. Then this minus will be joined to this carbon atom of this N group because it is positively charged, and this is because of the higher electronegativity. It will take up the electrons, the bonded electrons towards itself, it will minus. So this MgBr part of this Grignard reagent will be attached to this nitrogen. So it is going to be there like this, a addition product, intermediate addition product will be this NMgBr. And when we hydrolyze this, when we are going to hydrolyze this in presence of H+, it is going to produce the acetaldehyde with ammonia and MgBrOH Br. Okay, so reaction number 8, that is reaction with HCN, hydrogen cyanide with the Grignard reagent, we can able to produce the acetaldehyde. Reaction number 9, that is the hydrolysis of gem halide, gem dihalide, hydrolysis of gem dihalide. Gem dihalide means this is gem dihalide, CH3 CHCl2. When it is being hydrolyzed in presence of aqueous KOH, it will going to produce a unstable product plus 2KCl, and this product is not be stable, unstable. So it will lose one molecule of H2O and it is going to produce acetaldehyde. 10 number reaction, that is called Wacker reaction, Wacker process. Wacker process. In this process, ethylene has been reacted with the solution of PdCl2 in presence of the small amount of cuprous chloride and is oxidized by airy oxygen. So reaction is this CH2 ethylene plus PdCl2 plus H2, and we have to use CuCl2 as a catalyst and O2 oxygen air, and this is going to produce the CH3, CHO, PD and HCl. So in this way we are going to produce the acetaldehyde. So these are the 10 methods that we can able to produce the aldehyde. Okay. Now we are going to discuss the ketones. How we can able to produce the ketones. Ketones, that is number one, the reaction with dialkyl cadmium, and acid chloride. First, in this process, we have to know how we can able to produce this dialkyl cadmium. Dialkyl cadmium has been produced from the Gigner reagent, treating Gigner reagent with RNGX plus X is the halogen, it can be anything, but here RNGX plus cadmium chloride. Right? It will going to produce dialkyl cadmium and this RNGXCl. Okay, and this dialkyl cadmium is react with the acid chloride. We are taking the different alkyl group, acid chloride, and it is going to produce the ketones, which is having the alkyl portion. Alkyl group portion is different. One from the cadmium chloride, one from this alkyl group from the Gigner reagent, and another from the alkyl group from this acid chloride. So this is how we can able to produce the ketones. To discuss the 12 number reaction, that is the hydrolysis of gem dihalides. In this case, that we are using this reagent, that is 2,2-dichloropropane. 2,2-dichloropropane, when it is being hydrolyzed in presence of KOH, aqueous solution of KOH, it is going to produce a very unstable product, that is this. And afterwards it will going to produce the ketone. Ketone is this. Okay. So this is a 13 number reactions, 12 number reactions. Now we are going to discuss the reaction number 13. That is reaction with nitriles and the Gigner reagent. In this case, we have taken, suppose CH3Cl. Acetonitrile. We have taken, this is the acetonitrile, and we have react with this Grignard reagent, that is CH3MgBr, and it is going to produce a intermediate, just like we have discussed when we are discussing the reaction with HCN and this Grignard reagent, and this is going to produce the aldehyde. Now it will going to produce ketone when we use this acetonitrile, and this is NMgBr. And when it is hydrolyzed, it will going to produce the ketone. And another product is ammonia and also MgOH-Br. So this is how the aldehyde and ketone produce. Now we are going to discuss the production of the aromatic aldehyde and ketone. We are going to discuss the aromatic aldehyde. Aromatic aldehyde can be prepared from the substituted benzene. As for example, methyl benzene. Methyl benzene is toluene. This is methyl group has been this, and it is in presence of the chromium chloride, chromyl chloride. It is going to produce a chromium complex. This is a chromium complex, CHOCrOClH2. So this is a chromium complex, and when we hydrolyze it, it is going to produce the benzaldehyde. This is going to produce benzaldehyde, and the reaction name is Eatward reaction. Eatward reaction. Second reaction, when it is been, and here also we have to use the carbon disulfide, that is a solvent, CH3 CrO3 plus acetic anhydride, and it is going to produce a intermediate. This is benzylidene diacetate, and when it is been hydrolyzed, it is going to produce the benzaldehyde. And the reaction, this is by side chain halogenation of this toluene. Side chain halogenation of the toluene, we will produce this benzyl chloride. This is benzyl chloride, and when it is again hydrolyzed, it will going to produce this benzaldehyde. Okay. This is the benzene, and from this also we can directly able to produce the benzaldehyde by using the carbon monoxide and HCl in presence of anhydrous LCl3, and this is going to give this benzaldehyde, and this reaction is called the Gattermann-Koch reaction. Gattermann-Koch reaction. This reaction is called Gattermann-Koch reaction. In this case, you can see the carbon monoxide with the presence of HCl in presence of anhydride aluminum chloride, it will going to produce this. In another reaction, also when we use this HCl and HCl in presence of anhydride LCl3, that is also going to produce the CHO. This is called Gattermann synthesis. So this is the aromatic aldehyde, and now we are going to discuss how you can able to prepare the aromatic ketones. We are going to understand aromatic ketones. Aromatic ketones can be produced from the fidyl capped acylation reaction. Fidyl capped acylation reaction. In this process, benzene C6H6 react with the C5COCl benzoyl chloride in presence of anhydrous LCl3, and it is going to produce the benzophenol. It is going to produce the benzophenol, 6H5. So, and HCl. This is benzophenol. Okay. So all this, by this way, all the reactions we have been covered here. That is total 1560 reaction we have covered to know how we can able to prepare the aldehydes and ketones. First we have discussed the aliphatic aldehyde ketones, then we have discussed the aromatics. Hope that is all clear to you. This is basically a attempt to help those students who cannot able to afford the cost tuitions, and this will be helpful to them to achieve their targets. Thank you very much for watching, and we will meet in the next lecture.